Hello and welcome to video for section 3.3 rates of change and behaviors of graph. It says video 1, but I think there's only going to be one video for this section. So in this section, we're going to learn how to find the average rate of change of a function, use a graph to determine where a function is increasing, decreasing, or constant, use a graph to find local maxima and minima, and absolute maxima and minima. All right, let's get started. So the first thing we're going to talk about are rates and average rates of change. Examples of rates of change that you come across in your everyday life are dollars per hour, miles per gallon, miles per hour. All those are examples of units per other units. So the rate of change describes how the output value changes in relation to the input values. So the change in output over the change in input. And here is a nice formula for your average rate of change. Average rate of change equals, using function notation, f of b minus f of a over b minus a. And this is definitely something you want to write down in your notes for your formula, average rate of change. Let's do an example. This table lists the average cost of a gallon of gasoline in dollars for the years 2005 through 2012. So we want to find the average rate of change between 2005 and 2008. So here's my first input value, my a, f of a, and 2008 is going to be my second input value, my b, f of b. Okay? So here's my A, f of A, B, f of B. Let's plug it into our formula, f of B minus f of A over B minus A. So 3.30 minus 2.31 over 2008 minus 2005. All right, well, what is 3.3 minus 2.31? Let's ask Siri. What is 3.30 minus 2.31?
The answer is 0.99.
Thanks, Siri. 0.99 divided by 3. What is 0.99 divided by 3?
The answer is 0.33.
You guys do that? Use Siri to do your computations for you? The answer is 0.33, but now we need to think about the units. Let's look again at this problem. The units on the output, the 2.31 and the 3.30, remember those are dollars. So all the time we are subtracting $3.30, we are subtracting from $3.30, $2.31, so we got 99 cents, and that's our units in the numerator. In the denominator, the units are years, right? 2008 minus 2005, these are years. So we changed $0.99 in 3 years, or $0.33 per year. Now be careful. All right, so that's $0.33 per year for your average rate of change.
I don't have an answer.
Okay, seriously, now Siri's wanting to comment on everything. All right, let's see if we can find the average rate of change from a graph. All right, so what I would like you guys to do is look at this graph, using our formula for average rate of change, give it a try, pause the video right now, and try to find the rate of change between -1 and 2. All right, let's do this one together. Well, hopefully what you did was you went to your graph and you found the input and output values for x equal to -1 and the input and output values for x equal to 2. So my 2 points are -1, 8 and 2, 5. All right, let's plug that into my formula for average rate of change. So it's, let's call this A, f of A, B, f of B. All right, so 5 minus 8, that's f of B minus f of A, over B, 2, minus A, -1. That's equal to -3 over +3, which is equal to -1. So my average rate of change for the interval from -1 to 2 is -1. Now, we weren't given units on this problem. We don't know what the units are in output or input, so we don't put units on it. The average rate of change is -1. And something you can check is actually if you drew the line connecting these 2 points, let's switch to a different pen color. If you drew the line that connected these 2 points, it actually has a slope of -1, and that represents the average rate of change for that graph. All right, well, we've done it from a table. We've computed average rate of change from a graph. Let's try it from an equation. We're going to do the same thing that we've done so far along. We're going to find A f of A and B f of B and then compute the average rate of change. So my A is -1 and my B is 3. The only difference is before I read off from a graph what f of A was, I read off from a graph what f of B was. Now I have to use my function equation. So first I need to find m of -1. -1 squared minus -1. So -1 squared is 1, minus -1 is +1, so that's 2. So this is the point -1, 2. Let's find m of 3. Equals 3 squared minus 3, which is 9 minus 3, which is 6. So this is the point 3, 6, my b f of b. And let's do the subtraction. 6 minus 2 over 3 minus -1, which is 4. 3 minus -1 is 4. So my average rate of change for this one is 1 unit of output per unit of input on the interval -1 to 3. This says video 2, but I think we can just keep going. All right, we're going to talk about increasing and decreasing. So if a function is increasing, that means the average rate of change is positive, and we're going up as you go from left to right. So if you look at this function, it increases, and you'll have a positive average rate of change all the way until here. Then it starts decreasing, and my average rate of change would be negative, until again it starts increasing. And really the trick here is it's uphill for increasing and downhill for decreasing as you read left to right. You have to read the graph from left to right. All right, so we are going to answer this question. Where on the domain is the function increasing and where on the domain is it decreasing? Well, we know up until this point in -2, right here, from -infinity all the way to -2, it's increasing. -infinity to -2, it's increasing. So we'll write increasing. From -2 to 2, it's decreasing. And then again, from 2 to infinity, it's increasing again. All right, again, you just read those graphs left to right for increasing and decreasing. All right, let's talk about local max, local min, absolute max, and absolute min. A local max is a point in the function on the graph where it goes from increasing to decreasing. So it goes from increasing to decreasing, and we call that a local max because right around that area, so if you just draw a little circle interval around this area, it's going to be the highest point in the area. A local minimum is where it changes from decreasing to increasing, and it looks like that. And the same idea, in the little area around there, it's the lowest point. An absolute max is the largest value the function can obtain, and an absolute min is the smallest value the function can obtain. Okay, overall, the whole thing. So let's look at an example on a graph. Hang on just a sec. All right, I'm back. Just had to shut the door. All right. So let's see what we can find here. Let's start with absolute maximum value. Can you spot the absolute maximum value on this graph? So that's the largest output value the function obtains. Yeah, the absolute value is right, absolute maximum is right here, and it happens at 5. That's my absolute maximum. So the absolute maximum is 5, and it occurs, I'm just going to color in that dot, I want that good. And it occurs at x equal to, looks like these are each equal to 1, so -1.5. All right, let's find the absolute min on this graph. I need to squeeze in just a little bit, don't I? What's the absolute min on this graph? I bet you guys all spotted it. It's right here. Absolute min. Absolute minimum. And the absolute minimum value looks like it's at about -12.5. But it occurs at x equal to, I don't know, 2.1. We're ballparking here. So those are my absolute maximum, the absolute largest value, and my absolute minimum, the absolute smallest value. All right, what about local maximums and local minimums? Where does it go from Is there a spot where you can find where it goes from increasing to decreasing or decreasing to increasing? Well, here's one, right? Right here at this point, it goes from decreasing, it was going down, to increasing. So that's a local max. Right here at 0, it goes from increasing to decreasing. Sorry, that meant to say that was a local min. Local min. I should probably write this below. I think it'll be neater if I write it below. So we'll just draw an arrow right here. Local min. Then this one goes from increasing to decreasing. That is a local max. And there's one more. Do you see one more? Yeah, this one down here. Even though it's an absolute minimum, it's also a local minimum. Both things. That's also a local min because it goes from decreasing to increasing. All right, so that's it for this section. Basically, the important things in this section were how to compute rate of change from a chart, a graph, or given a function equation, and knowing the definitions of increasing, decreasing, local, and absolute maxes and mins.